Hello, 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 everybody. Root Beer here, and I hope you're as excited as I am. We're going to finish off Part B on the Grade 8 2005 Gauss paper from Waterloo. We're all the way up to question 20. Last question in Part B, then we'll move on to the hard stuff in Part C. So let's take a look if you haven't already. So question 20, a little wordy. A slack rope walker is much like a tightrope walker, except that the rope on which he performs is not pulled tight. It is slack. The rope is slack. So Paul, a slack rope walker, has a rope tied to two 15-meter high poles, which are 14 meters apart. Okay. When he's standing on the rope, 5 meters away from one of the poles, he is 3 meters above the ground. How long is the rope? Okay, we have some options here in the high 20s sort of ranges. Okay. Well, let's draw our picture. See what we can see. So we have the 15-meter high poles, and they are 14 meters apart. And the rope, I will represent it with yellow. Get that rope to connect to the top of the pole. There we go. Alright, and what other information were we given? Well, he's 5 meters away from one of the poles and 3 meters off the ground. How are we going to compute the yellow, what is the length, the total yellow length? That's what we want here. Okay. Well, the right angle that was in the bottom corner of our diagram gives us the tiniest bits of hint. Okay, if we're 3 meters above the ground, how about we just draw a line that's parallel to the ground? It's 3 meters above. So if we got 3 meters down here, we're going to have 12 meters up here. So 12 meters. And then we've got some right-angled triangles here. We've got 5, and if that's 5, what's left over? 14 minus 5, we've got 9. So the rope creates the hypotenuses for two right triangles. Okay? So if we solve for the hypotenuses of these two right triangles, we should be all set. So let's take a look at this first one. It's a height of 12 and a base of 5. Well, by Pythagoras, we're going to have the square root of 5 squared plus 12 squared. That's going to be this length right here. You can grab your calculator, or you could know that this is a 5, 12, 13 triangle. Okay. Knowledge of Pythagorean triples could certainly help you, but as long as you knew Pythagoras' theorem, you'd be all set. Grab your calculator if you need to, but 5 squared, 25, 12 squared, 144. Add them together, 169. You should be able to recognize that as 13 squared. If not, of course, your calculator can. Okay, so that's one of them. Now the other one. It's got 9, 12, and if you know your Pythagorean triples, you know you're going to get 15 here. If not, of course, we know by Pythagoras that 9 squared plus 12 squared is this hypotenuse squared. You might call it h squared or something like that. But you can solve for the hypotenuse by doing 9 squared plus 12 squared and square rooting it. Square root of 81 plus 144, square root of 225, and hopefully you recognize that that is 15. So what's the length of the rope? Well, the length of the rope is the two hypotenuses added together. So 13 meters plus 15 meters, and we're going to get a final answer of 28 meters. And that was one of our answers, the high 20s. Which one was it exactly? It was A. Okay, so we're going to flip the page in anticipation of question 21, the very first question in Part C, and that'll be worth 8 marks. So we want to do really well on it. So we're going to take a break and we're going to come back to it in the next video with our minds a little fresh, ready to try some of the challenging questions. Thank you guys for watching. I'll see you next time.